Hey. Welcome back. More product rule examples is what this is all about. So, let's do it. Okay. Let's do something like this. Here we go. Secant x multiplied by e to the negative x. More commonly, this will be written this way. It's just easier to look at this way. Okay? So, again, we need to realize that we have an exponential function multiplied by a trigonometric function. So because of this multiplication, if we take the derivative, we have to use the product rule. Okay? So, product rule, right? So the derivative of f times g is going to be, let's see how to write it, yeah? It's going to be f times the derivative of g plus g times the derivative of f. Okay? So we need each piece of the product as well as their derivatives. So, if f is the exponential, g has to be the trigonometric secant. All right? And their derivatives, well, this is kind of like e to the kx, and k is -1. So its derivative is going to be itself times the derivative of negative x. Okay? The derivative of negative x. Well, the negative is like a multiplication by -1, so this we can think of it as -1 times the derivative of x. And this, you can kind of see what's going on here, dx over dx. dx is 1, so this is just going to be -1. Okay? So we get e to the negative x times -1. Multiply, yeah. Uh-oh, okay. Sorry. Let me rename this. Instead of f, let me name it p. Because, we already have f here. P for product. Sorry. Okay. So f prime, e is negative x times -1. G prime, and we stated this. Derivative of secant is secant tangent. And again, gotta memorize these. If you're watching this video, you should already know. Okay. So there's all the pieces, f, g, and their derivatives. So the derivative of the product is going to be, let's do it here, f times the derivative of g. So f, e to the negative x, derivative of g is secant tangent. Okay? Plus g with no derivative. But then f prime, the derivative of f, is going to have the exponential. I like to write exponentials first. So negative e to the negative x. And then g with no derivative, so secant. Okay. Well, let's see, right? This is going to be e to the negative x, secant tangent, and then plus with a negative, so this is going to be a minus, e to the negative x, secant x. Okay? So this is the derivative of the product. you may see it written like this, but you might also see it written this way. We can factor by greatest common factor. E to the negative x secant x. And if I take this away from term number 1, all that's left is the tangent. And if I pull this out of term 2, think about multiplication, all that's going to be left is 1. So you may see it written like this as well. Okay? Cool. Can we do another one? Can we do another one? I think we can. What would be a good example? P2. Let's do a natural log. And let's do a polynomial and a natural log. All right. So, you know, there's P2 for the product. So the first piece, x cubed. The second piece, natural log. And we need the derivatives of each individual piece. Power rule, right? Bring the exponent down, reduce by 1. And then the derivative of the natural log is just 1 over x. All right. So, product rule, right? dp2 dx is going to be f, and then g with the derivative, plus g with no derivative, and then f with a derivative. There we go. Okay, and now we're just going to kind of clean up. X cubed divided by x squared, plus, and then I'm going to write the polynomial first, 3x squared, natural log x. All right. So you may see it written like that. And you can also factor by greatest common factor an x squared, leaving 1 plus 3 natural log x. Both of these are correct. One's factored, one's not. And yeah, more product rule examples. How much time have we gone? If I can, where is the time? 8 minutes. See if we can do another one. A third one. Let me think. Do something like this. P3. Let's not do that. Let's do 5 cubed root of x squared times cosine x. Okay, so first thing is we have a constant multiple, and we've already gone over that in detail. So this 5 is just going to multiply everything out front. So then for the product, we have the radical part, and then we have the cosine part, okay? So basically, my f is going to be the cubed root of x squared, and another way to write that is x squared to the power 1/3. And we have a power to a power, so we multiply the powers, x to the 2/3. So there's f, and we also need g, right? So that's our cosine. So the derivatives, right? The derivative of g, negative sine. derivative of f, power rule, right? 2/3 x to the 2/3 minus 1. So 2/3 minus 3/3, negative 1/3. So there's all the pieces. And let me just simplify this a little bit. This is like 2 over 3, and then cube root of x, right? Because the negative exponent's going to go downstairs, become positive, and then x to the positive 1/3 is the same thing as the cube root of x. So now we have all of our pieces. So let's write the total derivative, right? dp3 dx is going to be, well, it's going to be f with no derivative times g with a derivative, so negative sign, plus f with a derivative, so that's the 2 over 3 cube root of x, and then g with no derivative, so that's going to be cosine x, which we can just kind of throw right up here. Okay. All right. Let's see what happens now. So in the first term we have a negative sign, so negative, and then x to the 2/3 we can write as the cube root of x squared, and then the sign is outside the radical, and then plus, let's see, I'll just write it like this, 2 cosine x over 3 cube root of x. All right, so that's perfectly correct. But we could see it in a different way, because now we have two fractions with different denominators, so our common denominator is going to be 3 cubed root of x. All right. So we need to multiply top and bottom of term 1 by 3 cubed root x. So minus 3, and then cubed root of x squared. We also need to multiply by the cubed root of x. So we can do that this way. Okay? Over 3 cubed root x. And then we have the sine x up here, still. And then plus 2 cosine x. Sorry, I'm running a little in space here. Okay. And now inside we have x squared times x, which is x cubed. And then the cubed root of x cubed is x. So we actually wind up with this. Negative 3 x sine x plus 2 cosine x over 3 cubed root of x. So you may see it written this way as well. All right, there we go. 3 more product rule examples. Blair out.